Okay, you're going to build a synthesizer. Now, how do you even start a project like that? Well, the first thing that we need to do is we need to ask ourselves, what is a synthesizer? What does it do and how does it work? Because we really need to understand the kind of architecture of the instrument if we're going to be able to build one and design one ourselves. Because the whole point of this little project is that you're not going to build my synthesizer necessarily. We're just going to work through the steps together and you'll come up with your own instrument out of this. So this is how do we build your synthesizer. So a good starting point is the question, what is a synthesizer? Well, a very simple, very basic jumping off point might be an electronic instrument for generating and controlling sound. Okay, it's a musical instrument. We play it like any other musical instrument. It has a kind of interface that we can interact with musically to perform. It's generating synthetic sound. I mean, it might be a sampling instrument, a sampling synthesizer, but for the most part here we're going to work with kind of classic waveform synthesis. And then a synthesizer can usually process or control or manipulate that sound, okay? So that's going to be our jumping off point here. An electronic instrument for generating and controlling sound. So with that in mind, we need a very basic architecture. And we'll start kind of zoomed out. We'll start at the kind of highest level and slowly we'll break it down into parts that we can then start to build up and create ourselves in Max. So synthesizer starts with a sound source, okay? Then the signal from our sound source moves down, and then we can modify it, we can process it somehow. And then finally it goes to the output, okay? It's very simple, 3 steps. Sound source, modifier, output. Okay, job done. We understand that? Now we can start to move kind of down to a lower level. We can zoom in on the architecture of the synthesizer, okay? So what might our sound source be? Well, kind of said already, but waveforms, okay? We need to generate some sort of waveform, and this is usually done by an oscillator, and that's going to be the focus of today's video. We're going to look at oscillators and kind of working with them in Max. So what comes after the oscillator? Well, in our very basic framework, we move on to the modification stage. Now, the modifier can do lots and lots of things. This could be a whole range of kind of different effects, but we're going to keep things quite simple and kind of classic synthesis here. So the most common modifier to our sound source would be a filter. Okay. Now, this style of synthesis is generally known as subtractive synthesis. Okay. I like to think of it as sculpting synthesis. So what's happening here is we're feeding our filter a really rich sound source. Okay, this is a complex oscillator, a complex waveform that we can use the filter to kind of sculpt the kind of harmonic shape of our sound. Okay, this is the form of synthesis that we'll work with today is known as subtractive synthesis. Now the modifier can include other things. The most common after the filter would be the amplifier. Okay. Now the amplifier we can imagine as opening and closing to kind of create the shape of our note. So if you imagine pressing down on a key, the amplifier opens, and then when we take our finger off the key, the amplifier closes. So we get a note start and a note end. Okay. And then this signal is then fed to the output. So a really general design schematic, the architecture of our synthesizer might look something like this. So we've got 2 oscillators, and that's in order to create a kind of complex waveform that we can then sculpt with our filter. The output goes to an amplifier, and then the output of the amplifier goes to our main amplifier so that we can hear it. But we've got all kinds of other options for control, okay? Because remember, this is a musical instrument. We want to be able to play it. It wants to have kind of certain interactive abilities. So that could be the keyboard controlling the pitch of the oscillator. That could be linked to an envelope that controls the amplifier, tells the amplifier when to open and close. We can have other things like LFOs, which are low frequency oscillators that will kind of pulse and manipulate things like the filter frequency or the cutoff frequency, and really kind of start to do interesting and dynamic things to our synthesizer's sound. So, without going on too much, we need to think a little bit about our sound source. Okay, we need to think about what our oscillators are doing. So we've got 4, maybe 5 basic waveforms. Okay, now here they are. These might be familiar to you, but just running down the list, we have a sine wave, we have a triangle wave, we have a sawtooth wave, and we have a pulse wave, which is commonly known as a square wave. Okay, and this can be changed into sort of other pulses. And then there's sometimes a 5th waveform option, which is noise. And we'll talk about this a little bit later, but it might sound noisy at first, but it can be really, really useful if we use it well. So how do we turn these basic, simple waveforms into a complex waveform that we can then sculpt with our filter? Well, it's just a matter of combining them, essentially. And that's what we're going to do now. We're going to use Max to create a complex waveform and listen to how that works. Okay? Okay, so here we are in Max. I've created a new Max patch by going to File and New Patcher. Just a quick word before we get started. I'm using Max version 8, and I'm using it on a Windows operating system at the moment. So you are probably using something different. You might be using an earlier version of Max, maybe Max 7, and you might be using it on a Mac. But ultimately it's the same. Max 7 and 8 are quite similar, and they look sort of very similar as well. So don't worry too much. Some of the keyboard shortcuts that I use might be a little bit different, but I will try to kind of call out the differences or use kind of manual buttons to create things as we go, just to take care of any difference. So what we want to do is create a complex waveform in Max. And we're going to do this by combining simple waveforms. So I'm just going to create a new comment just so we have a list of what waveforms we want to make. So we know that we want to make a sine wave, and we want to make a triangle wave, and we wanted to make a sawtooth wave, and a pulse wave. And maybe if we have time, we'll make a little noise wave. Okay, so Max makes this really easy for us because it gives us objects that take care of most of these functions. Now the names are a little different, but don't worry, you'll kind of pick them up. This is something that beginners find hardest about Max, just knowing what name is linked to what object. So unfortunately there's no sine object, but there is a cycle tilde. Take note of the little tilde that comes at the end of an object name. That usually denotes that it's an audio object, so it's going to generate something in this case. So there we go, we've created a sine wave, but we can't hear anything obviously, so there's a few more steps. We need to hook this object, this function object, up to an output so that we can hear it. Okay, so we're just going to do that now. First of all, I'm going to use the keyboard shortcut N. It's the same on Windows and on Mac. And that's just going to give me a blank object. And then I'm going to type gain actually, and this is going to autocomplete. And you'll see that when I do this, the UI changes, the user interface changes. So boom, there we go. Now I've got a little gain slider, like a fader on a desk. So I'm just going to hook this up here. And then this is going to be my gain slider for my sine wave, and I'm just going to hook this up to the output. Now we're going to use the Easy DAC. This is an easy digital or analog converter. Okay, and this is also going to change the UI. There we go. We have a neat little output button. So I'm just going to check the volume down here so that it doesn't blow up in your ears. And now what I need to do is I need to turn on the audio driver. So there's 2 modes in Max if you've not used Max before. There's an editing version where we can click on things and grab them and move them around, but we can't necessarily interact with them. And then you can lock the patcher down here in the bottom left hand corner. If I click lock, you'll see that my grid disappears, and now when I click on things I can't move them, but I can interact with them. So I'm going to turn on audio, and I'm going to drag this up. Now we can't hear anything. Now that's because our oscillator needs it needs an argument. It needs to be told something. An argument is like information. So in this case, our cycle object, our sine wave, needs to be given a pitch. It needs to be told what frequency it is going to play. Okay, and we can do this manually like this. So I'm going to say 440 hertz. That's how a synthesizer generally will read pitch. It'll read it in hertz, frequency in hertz. So I'm telling it, now play a sine wave at 440 hertz. Now when we listen to this, you can hear it. Now, you'll only hear this in the left ear of your headphones or left channel of your speakers at the moment, because you'll see that we're only patched up to the left outlet, okay? So I can just move this across now to the right outlet. So we're copying this channel. It's going to both left and right output. And now as I turn it up, it's in mono. Lovely. Okay, well, now what's next? Well, firstly, I'm going to create a new number. I typed F there just to, it's a shortcut for a floating point number. Okay, so it's a non-integer number. And I'm going to connect this because now this is going to do the job of telling our oscillator what frequency to play. So if I turn this up and then I scrub this number around, you'll hear the pitch of the synthesizer change. Hear that? Okay. So we've got a little bit of control of our oscillator now, okay? We're a way off from making this a musical instrument, but you can see how the gesture of me sliding this number around is changing the pitch, and you know, in a little while this could be something musical, okay? But this is a simple, basic waveform. And what we want to do, remember, is create a complex waveform. So now I'm just going to go ahead and I'm going to create new oscillators to take care of each of the waveform types that we've listed here, okay? So this is going to take a little bit of remembering on my part. So I'm pretty sure that the triangle wave is just called tri. There we go. Now, this is going to take a couple more objects, a couple more arguments, but we don't really need to worry about that at the moment. If we did want to find out what they were, I would open the help file for this. So I would just right click and open try help. And that's going to give me a little pop-up that's going to tell me all about this object, okay? And I can do this for anything in Max. I can just right click on anything and hit open, and it's going to pull up all of this information that tells me how this object works, what kind of arguments it takes, what it can do, how it can be used. Really, really helpful stuff. Now if I open this one again, now if you look over here on the right hand side, this might be a little bit small on your screens, but there's a See Also section. And this is really helpful because it's going to show us related objects to what we're currently looking at. So if I just look down this list, I see at the top there I've got cycle, sine wave, oscillator, and then I've got other related ones. So here I've got a sawtooth signal for a phaser, a rectangular oscillator, so a pulse wave. I've got another sawtooth oscillator, and I've got triangle oscillators and things like this. So this is really helpful because now I can just very quickly remember which ones I want. I'm going to create my sawtooth with that, and I'm going to finally create my pulse wave with rect. And there we go. I've got our 4 basic waveforms. So I'm going to hook these up to the same number, so they're all playing the same frequency. They're playing in unison. And then I'm going to hook these up to the output. I'm going to quickly do a little trick just to sum these. So I'm going to create a new object. I'm going to put an asterisk in, asterisk tilde, and what this is going to do is this is going to multiply our signal. So it's going to sum all of these different oscillators together, these 4 oscillators. It's going to mix them together effectively, but I want to multiply them by a small amount because I want to attenuate that signal, because otherwise I've got the output of 4 oscillators all being sent to my headphones at once, and that's a little bit much. So what I'm going to do is I'm going to say 0. Let's make it quite quiet for now, so let's just say 0.1. Now, let's get rid of this for a second, move our multiplier over here, Now I'm going to send all of these to this left inlet on the signal multiplier, and then patch this down here. Now if I reset this number to 440 like we started with, all of these will now be playing at 440 Hertz. And we can listen to this. It might sound a little bit messy. Okay. Not the nicest sound in the world. Okay, let's start to play with the balance of this, because at the moment this is kind of brash, nasally sound. It's not particularly nice. But as we start to control things and balance the different oscillators, we can come up with something interesting. Okay, so now I'm going to keep these same oscillators, but I'm going to change the routing of that gain slider so that we can control the volume of each oscillator individually. So I'm going to go back into edit mode, and notice when I switch between edit mode and sort of locked mode, you'll see the grid on the background disappear and reappear. That's how you know which one I'm doing. I'm just going to add a quick note here, a quick comment, because this is always really, really important to do, so that when we come back to more complex and more complicated patches later on, we remember what's going on. So I'm just going to say this is in Hertz, and just so we know, this is the frequency of all the oscillators. Oh, my spelling's terrible. Right, there we go, just so that we know when we come back to it. I'm going to clean things up a little bit. I'm going to get rid of this. No Dropbox, go away. Now I'm going to switch things around. So instead of having everything go to one multiplier to attenuate and then go to the gain slider, I'm going to create a bunch of gain sliders. So I'm going to create a new object with n, and it's called gain. I've got a bunch of these. Let's just shrink them down a little bit. Notice when I zoom in, there's two outlets here, and when you generally create one, they're quite close together, see? And you can mix them up. So I just drag this out a little bit just so it's easy to spot which one is which. So now I'm going to create this. And if I click on an object and hold Alt and drag it, it's going to create a copy. It's a really quick way of just making a bunch of things. You can copy and paste like in other software as well, but I just like this as it's quick. I'm going to move this out of the way. Now I still want to do the same thing. I still want to attenuate everything a little bit. So multiply, tilde, and let's just say 0.5. And now, once again, everything is going to come out of the left outlet of our gain slider and go into this, and then over here. So now, if I wait and go back in, if I turn. Now we just have our cycle, we just have our sine wave, but I can then slowly turn up the triangle wave and we can hear the difference. I'll just turn this up a bit. Hear how the harmonics change and the tone of the sound kind of shifts subtly. Now one thing to do would be to see this, so I'm just going to very quickly create a scope. This is an oscilloscope, and it's going to show us what's going on with this sound. Now, automatic mode that I just put on here, I did Control I, or Command I on a Mac, which will bring up the inspector. I think automatic mode is only available on Max 8, so if you don't have it, don't worry, but it's just going to show us what happens at the moment. So let's turn all of these down, and you'll see this is a sine wave. Okay, this is a straightforward sine wave. Now as I change this, see how the waveform changes. Now what happens if I slowly bring in the pulse wave, the square wave? See how it destabilizes our waveform. Now if I bring back in the sine wave, we see something else happen. I I can change this. And as we play around with this thing, you can create some really interesting, complex waveforms. Okay? And remember, this is what we wanted to generate, so that then all of this information can be fed into our filter, and we can start to sculpt or subtract from this complex sound. Okay. Now, as it stands, just having all of these oscillators feeding into each other at the same pitch is not particularly interesting, and frankly it kind of doesn't sound that nice. So what I want to do quickly is I want to just look at how we can change this frequency that they're getting to create something a little bit more interesting, but at the same time still make it one pitch, like rather than just sending them all separate unrelated pitches like building a chord. Now we could do this really easily because we could just shift the octaves of the frequencies. So I'm just going to clear some space for a second. Let's just get rid of this, move this down here. In fact, actually I'll just zoom out a little bit. Hopefully that's still readable. Now, at the moment, all of these oscillators are being sent 440 Hertz, okay? So they all get exactly the same pitch. Now, what I'm going to do is, I'm going to just do some really, really simple division and multiplication to switch the octaves. So now what I'm going to do is, I'm just going to say, what do I want? I think I want that sine wave, that really pure fundamental tone. I think I want that to be an octave lower. So rather than have to sit there with a calculator and figure out, okay, well, what is an octave below 440 Hertz? All I need to do is divide 440 Hertz by 2. So I'm going to do like this, divide, which is the forward slash, divide two numbers, and then I'm going to say by 2. It's really important though that you put in the full stop at the end, because that's going to tell it to keep this number as a floating point number rather than just round to the nearest integer. So let's see, if I take this, patch this in, and now I'm going to create a new floating point number just to check it, see what number we get. So I'm going to press F, there we go. I'm going to send that number here, and let's also send it to the sine wave. Now if I just put 440 in again, boom, 220 Hertz. That's an octave lower. So I'm just going to turn all of these down, turn our audio back on, slowly turn sine wave back up. Now if I turn up the triangle wave, which is still at 440 Hertz, we'll hear the difference now. Okay, this is getting confusing, so I'm just going to delete that. Whoop. Now, what if I went lower? Oh, there we go. This is looking interesting in my oscilloscope now, and it sounds quite nice. We've got more of a separation, there's more bass in that low, pure sine wave, that fundamental. So if I bring in these other ones now, it's not really changing a whole lot. Okay, so let's try this again. Let's try and repeat the same process. Let's do it now with my pulse wave, my square wave. Let's take this down an octave. So now I've got my sine wave down 2 octaves, my triangle wave the same original pitch, my sawtooth wave at original pitch, and my pulse wave 1 octave down. Now each time I do this, I just have to give this a little bit of a wiggle just so that it changes all of the numbers. So just to check, oh no, just to check, let's have that there, so we can see that these are now all at different pitches. And when I turn this back up, let's get these out of the way. I'm going to add one more. I'm going to do something different this time. This time I'm going to take our sawtooth wave up an octave. So I'm going to multiply it by 2. Hear that? As the sawtooth wave comes in, that's an octave above. Pulse wave is an octave down. Sine wave is 2 octaves down. Triangle staying static at the moment 437 Hertz. So we've got a bit more spread here. We've got some interesting things going on, and because this is just in octaves, we're spreading the kind of harmonic series around a little bit. Okay, now we don't really have to worry too much about the perfect just intonation at the moment. I don't really care about that. That's something we'll get into a little bit later. But for the time being, I do want to make this feel a little bit more like a musical instrument rather than just a test tone generator. So what we need to do is we need to solve a little problem. We need to say, okay, how do I control this here, this frequency expressed in Hertz? How do I control it by MIDI, which is a fundamentally different format? It's a different mode of communication. It's a different, it's just a different number. So how do I map one number onto another? How do I make MIDI understand what frequency is? Or how do I make an oscillator understand or care what MIDI is? Because normally they don't. Well, Max actually, again, makes it really, really easy. We just need to know what we're looking for, okay? So I'm just going to move some things around just to clear a little bit of space. You very quickly tend to run out of space. I'm just going to get rid of these because I don't need these anymore. Move this over here, move this over here. And keep our frequency at the top. So, a nice little thing you can do in Max is if I just grab everything. Now I have to try and remember the shortcut. Okay, I'm not going to remember the shortcut. There we go. Root patch chords. Arrange root patch chords. There we go. It's going to clean up all of those messy patch chords. Okay, so our question is, I have a little MIDI keyboard like this. You've probably got a different one in front of you. How do I get this to speak to our oscillators? So we know that MIDI data is expressed in MIDI numbers, which are kind of just straightforward integers, usually from 0 to 127. And that's unrelated to frequency expressed in Hertz. Max is going to take care of it because it has a handy little object called M2F, which, as you can see here, converts a MIDI note number to frequency. Hey, that's exactly what we want. So now I could send it a number like 64, and it knows that that is a specific pitch. So let's just turn this back up. And now I'm just going to use my arrow keys to just move through the chromatic scale. But that doesn't answer how we get the keyboard to do anything. This just gives us a way of translating one format into another. So to bring the keyboard in, there's another Max object called note in. Now there's a whole bunch of objects related to MIDI and MIDI data. If you want to find out what they are, again, I'm just going to pull up that help file, and you'll see kind of a whole host of related MIDI objects down here in the right hand side, or I can click on this question mark up here and there's a reference, and there's also tutorials. Max's tutorials are really, really amazing, really helpful. And look, there's all of this information about how to work with MIDI in Max. So for the time being though, all we want is this note in. So if I go back to my lock screen, there we go. If I double click it, you'll see that I've got all devices by channel. So that's just going to listen for all MIDI information coming into my computer. And if I just create a couple of numbers just so we can see what's coming up. These don't have to be floating numbers. These can just be integers. So I use the shortcut I to make those. I'm just going to hook those up. So if you haven't seen this already, if you hover your mouse over an inlet or an outlet on an object, it will tell you what it needs and what it is sending out. So here on this leftmost outlet of note in, we can see that it's sending out pitch. The next one along, velocity. And then the last one, MIDI channel. So now, fingers crossed this works, if I press a key, hey, there we go. We can see the numbers changing, and we've got pitch numbers. So let's just put this down here. If all we want is this pitch number, let's get rid of that now, this MIDI note number, which is going to be translated through the M2F object into a frequency in hertz, we should now my keyboard playing is not good, but you get the idea. Okay. So now we have musical, my performance notwithstanding, control of our oscillator. This really feels a bit like a synthesizer now. We have musical control, musical interaction of this sound. But I have a problem. The problem is that, you know, music has reached the point now where we are 50, 60, 70 years past the birth of the synthesizer, okay? When I make this video, it's 2019. Why, in 2019, do we still insist on using things like this antiquated interface, this 12-tone equally tempered keyboard? Why do we want to use this to control something as powerful and as exciting as a synthesizer? There's so much more out there. And that's what we're going to look at a little bit later after we finish building our synthesizer. We're going to look at using Arduino boards and kind of various sensors and hardware controls to control aspects of our synthesizer, okay? Now the next few videos are going to sort of focus more on just building out this synthesizer. So we've got our first sound source now, and we can start to add things. We can start to work with filters and shaping our sound and doing more interesting things. But ultimately, you know, this is your instrument to play around with. So, you know, try different numbers. See what happens if, and this could go really horribly wrong. See what happens if we just put in random numbers. Let's see if I put in 1.3. Now my sawtooth wave. Oh, that's not bad. Oh wait. Oh yeah, not great. Oh dear. Okay. Back to the drawing board. Play around with the instrument. Come up with interesting things. Ask yourself, okay, well, why do I want just straight octaves? Why couldn't it be... What happens if I put it 6 octaves below, so everything is just massive sub-bass? Play around, switch numbers out, get things wrong, and make mistakes, because when you start to make mistakes, that's where you kind of come up with, to use the Bob Ross term, happy accidents, okay? That's where you make fun, weird little strange devices and strange instruments, okay? And that's one of the beautiful things about Macs. There's a lot to go wrong, and therefore there's a lot of serendipity kind of just waiting for you in the instrument. Okay, so that's oscillators. That's the sort of start point of our synthesizer. Play around with this, come up with some cool things, look at Max's other forms of oscillators, other wave generators, and see what happens there when you start to play around with them. You could have, you know, 6 sine waves, all tuned to slightly different pitches, and a bunch of sawtooth waves. There's no reason that it has to be these 4. You could use as many or as few as you like. But yeah, have fun playing around with it. Thanks. Okay, I finished filming the video, and then I had a little idea and I wanted to do it, so it turned out kind of fun, so I thought I'd share it with you. So what I've done here is I kind of thought, rather than just doing like multiply by 2, divide by 4 to change the octave, I thought, well, we can do that with MIDI numbers, because we know there's 12 notes in an octave, right? So for a MIDI number, all we have to do to move an octave up or down is add or subtract 12 from that note number. So what I did was I made a little multiplier thing down here. So now what's happening is, if you multiply 1 by 12, you get 12. And if I add that to whatever my current MIDI number is, so I use the little add addition object, now if I add an octave above MIDI note 44, I get MIDI note 56. If I don't do any, I keep 44. If I go down an octave, so -1, you see my MIDI note shifts down to 32. So in effect, what that means is I get a note. If you hear that, ooh, and now I can just use my arrow key to move through octaves. Which is kind of fun. And one thing that I really love to use in Max is I love to use randomization. Okay, so there is an object just called random, and whenever it gets triggered, it generates a random number between 0 and whatever you ask it for. So I'm going to say generate a random number between 0 and 8. Okay, so anytime this gets triggered, it's going to output a random number between 0 and 8. Now I'm going to offset it, so I'm going to create a new object, and I'm going to subtract space 4 from that. So now my range of my random number is going to be from -4 to +4, okay? And it's going to get triggered anytime I change the note. So let's see what happens. This might go horribly wrong. So I'm just playing the same note, and it's generating, switching into random octaves, which is kind of fun. Okay, maybe 8 was too far. But we could really quickly, really easily modify this, right? So at the moment, they are all receiving the same frequency. So all of our octaves are tuned the same. So I'm just going to get rid of these for a second. So there we go. These are all the same octave now. But what we could do is we could just copy this. So I'm going to select all of that little octave switcher device that I just made, and I'm going to encapsulate it. Now, because I'm on a Windows computer, I can't quite remember the shortcut. Oh, this is embarrassing. There we go, encapsulate, Control-Shift-E, and that's just going to create a new little subpatcher. So I'm just going to call that octave switcher. Now if I wanted to see that, it's all still there. There we go, it's in another window. It's just hidden now, so it makes it smaller, it takes up less space, and it means that I can very simply, I'm just going to get rid of this for a second. I'm going to drag this over here, and I'm going to create 4 of them. I'm going to hook them up. Yep. So now, all being well, anytime I play a note, each of those 4 oscillators is going to receive that note, but in one of 8 different octaves. Oh god, I hope this works. Well, that was interesting. Okay. Yeah, so that's just an example of you know, how you can kind of play around with these things. I really encourage you to use random. I mean, maybe not too much, it can be overkill, but if you use it kind of nicely, and maybe a range of 8 was a little bit much there, but random can do some really interesting and really exciting things. So have a play around with that, try that out if you want, and yeah, come up with some cool stuff. Cool.